All right, so as you already saw some of my notes, I'm going to be talking about testing, and I'm mostly going to be using slides, excellent slides made by Dan Stahl. Is Dan in the audience? Not. Was he here first, Dan? He was here earlier. So these. Is it? Oh, yeah. These things work better. Turn them on. Okay. Okay. Gonna do it live. Do it live. Okay. So these are slides that made by Dan Stahl. Oh yeah, so I'm Paul. Hey, how's it going? Welcome back. 3 days, you guys made it. This is like an awesome turnout. I'm pumped to be here. I don't know if you guys are. All right. I just wanted, Barry got a chance to do a stand-up. I kind of want to do stand-up too. This whole academic thing, in case it doesn't work out. I would just enjoy this. Thank you. Any hecklers? No. All right. Okay, so we're going to talk about testing, and yes, and this and the works.
The tarball is up now.
Okay.
You wrote the agenda.
Cool. So yeah, we will be looking at some code, and hopefully I'll be able to navigate there. And all right. So many of these slides are made by Dan Stahl, and you can see the date on that. So this was the bootcamp 2 years ago, I believe. So this is like almost exactly 2 years ago. That's scary, and they're very good slides. So if something, with testing, if something's not broken, you don't need to fix it. So that's what I'm doing here. All right, so testing. How do you know that any of the packages that we told you are any good? I mean, you can use them, right? But how do you know that they're going to give you accurate results? Well, you can check some of them by hand, right? But the idea is that if you have an automated way of writing down tests of what sort of as a contract, what it means for your software to work, or what it means for the software that you downloaded, what it means for that software to work, then you can have your users verify for themselves that your software works the way that you intended it to work. It's not just a trust me, or it's not just a it works on my machine. It's a here, I'm showing you everything I've got. These are the specifications. This is what it means for my code to work. And you can verify for yourself. So, sorry, I have trouble seeing here. Maybe I will have to case you back. All right, so Nose is the sort of the standard tool that we have, that we use in our community in Python. There are many Python testing frameworks of varying popularity, some used only in some communities, some specifically made for a particular project. Nose is the one that pretty much all of the scientific Python stack packages use. And then we'll also talk a little bit about PDB, and I already showed you, and I think others have as well, how to use PDB inside of IPython and sort of how to move around. So hopefully we'll get through some of that as well. And as always, feel free to interrupt me and ask questions. And tell me, when do I need to be finished by?
Let's see, we had you until 11:40.
Okay, cool.
But
okay. All right, but before we can get to testing and debugging, let's just recap some things that were covered yesterday in dealing with errors and exceptions. And then Dan had some nice notes in here about the traceback module and how to do logging as well, because these are all sort of aspects of good software development that are useful for, so testing is one way to proceed forward, right? When you write down your test, what it means for your package to work. But when it doesn't work as expected on a given machine, how are you going to go about tracking that down, right? When it doesn't work, does it just not pass the test? It doesn't sort of meet the requirements. Maybe it's some numerical accuracy that your algorithm has. Is it just that? Or is it that it actually throws an error because the way that you coded all of your paths to files are with the /, which is, which works under Unix and under Linux, under Mac OS, but under Windows, that's not going to work. And shame on you for not using OS path module and OS path join to join different slugs and different directories. Because that's the beautiful thing about Python. And forgive me if I'm rehashing some of these things, but this stuff was important because the beautiful thing about Python is it is a cross-platform language, right? I see a bunch of, Mac symbols staring at me, but I also see a bunch of, Lenovo and Dell machines staring at me as well, right? And those could be running Windows, and you could be running Windows on your Mac, and, all of this stuff works. And it works because we're using Python, and you want to write your code in order to gain the most benefit out of Python, right? You don't want to write things that are specific to the operating system that you're on. You don't want to write things that are specific to your computer so that after you lose it, it doesn't work anymore. Okay. So that's errors, exceptions, traceback module, and then logging will also sort of enable you to keep track of what's been what and to sort of expose inside of your code a very verbose traceback of what's actually going on. Have that code live there, but not have it show up until the moment you need it. So while you're not debugging, while everything is going fine, you just disable the logging, or you log only the critical sort of error messages. But then once you're getting down to the nitty-gritty and there's some bug that you're having trouble fixing, then you just flip and, on one line in your code, you just flip a switch, and then bam, now you're getting, hundreds of different things, every minutia of everything that your code has changed and everything that it's doing. Okay, so exceptions, or syntax errors rather, are something that will be caught as soon as you type it in. It's just not valid Python. Hopefully, if you've at least run your code, right, it's valid Python. Now this could become an issue as, so I'm going to take an even further sort of step back and an even larger view of what it is that we're doing here. So we're writing here, we're writing code, we're writing Python. We're probably writing Python using a particular version of Python, right? And Python is, as a language, does evolve, right? And so some things that are valid on your Python 2.7 are no longer valid in Python 3. And there are let me just take care of this. And there are conversion utilities that'll let you go from Python 2 to Python 3, or from Python 3 to Python 2. But it's just something to keep in mind that these may pop up in your code that's valid on your machine, but for a later version of Python, like the with keyword didn't become built into the language until Python 2.6, I believe. So if you have old users on Python 2.5, like Josh's telescope, right, is still running Python 2.2 or 2.3? Python 2.3 from 2003 or something like that. Those are syntax errors. There's also exceptions, which is like a divide by 0, right? That's ill-defined. You'll get a 0 division error. Or maybe it's something where, file system full, right? You want your code to sort of catch these things, and this was talked about yesterday. You want to be robust against these sorts of things. So the syntax errors is hopefully something that'll get caught early on. If your code is running at all, like if the thing that you wrote ever gets down an execution path where it runs, you'll be free of syntax errors unless it's the case that your users end up on a slightly different Python version, or maybe you upgraded your operating system. Now it's a new Python version. Something that used to be valid isn't no longer. For the most part, that's not an issue. I don't mean to scare you. I just mean to give you sort of a real picture of what it's going to be like to be coding sort of for the long haul. Okay, so the traceback module is great. I actually didn't know about this, and even though I think I may have attended this bootcamp, I forgot it. And then Fernando Perez gave these slides, and I also didn't catch it. So this is a great way to sort of get inside of what errors your program may be running, and then allow it to continue running. Like if it's something non-critical, you just want to report it. And you might see that actually scrolling by in the notebook sometimes. When you have a IPython notebook server, there are errors that will occur, but they sort of just scroll up and they're there if you want to look at them, but they don't break your program. The notebook keeps on running, right? And these slides got posted here, so okay. Okay, so this is code that sort of demonstrates how to use the traceback module, and you guys can play with that on your own. Okay, the next thing is logging, and so this I already sort of alluded this and covered this in great detail, which is that you want to be able to, so this is what I was talking about. This is the log level is that switch that you will flip when you go to, so maybe normally you want to log warnings, you want those to show up, but now you're still, the warnings aren't up, there aren't any warnings that are popping up in your code, and still the numerical result is wrong, and you're not quite sure which execution path is being taken for this user on this platform. And you just tell them, can you just change this one line? Can you change that logging.warning to a logging.debug? Because that way I'll get a lot more information about what's actually going on inside the source code, right? So in this one thing, and the way that you actually use the logging is demonstrated right here, right? So this defines sort of the level at which you want to be informed about a given event or a given set of strings. And of course, since these are just strings, you can put in variable names in here. You can interpolate into them, and so it's just, I mean, it works pretty great. And so in this case, if the log level is a warning, then this debug message actually won't show up in the log, right? Because it's below the log level that we currently care about. But once, the warning will show up, and so will the error, right? So and that's demonstrated here.
Remember yesterday when we were doing the object-oriented, I think, second lecture, we actually were creating our own log file. So whenever we did init or a del, we were basically writing into a log file. There might have been missed by many, but we were essentially doing a flush. So we were basically explicitly saying, here's a string, force it into the log file, and even if I haven't yet closed it, make sure that somebody who's looking at that file will still see that appearing inside the file. Logging is basically doing all that for you, making sure that if you have multiple Python codes that are writing the same log file, that you're not going to get conflicts.
Yes?
It's not clear to me what it would be giving me if I wanted to set it at debug level.
So at the debug level, anything that you invoke with logging.debug, so and I'm sorry, let me just cover one thing and then I'll get back to you. The way that this is written, this is a way to do logging. Just sort of, what's the word I'm looking for? It's sort of a simplified way of doing logging. On the next slide, I'll show you how to do that in a more component by component way to have a logger for sort of each module and things like that. So here we're just using the logging module plain old simple. There's a way to instantiate a logger object from the logging module that you can have many different logger objects sort of that are maybe task related or module related, and you would do the same thing. But to answer your question, what logging debug in this case will be sort of a no-op for this log level. So is this not making sense? So there's different, let me cover this in a different way. There's many different log levels, right? So there's log level of debug, info, warn, warning. I'm just reading off in the red over there, okay? For a given log level that's set for a logger, in this case, we're just using the sort of the root logger. There's just one logger here. It has its own level, and it will only report, it will only log messages that are equal to or higher, so sort of further down the list of what its current log level is, right? I'll get you in a second. And does that make sense now?
Yeah, yeah. I mean, I understand that, but I can see if you wanted to report warnings, I can see what kind of messages you would get.
Yeah.
But just by saying debug, it's not clear to me what gets reported.
Oh, so debug here is just a word. And warning is also just a word. These aren't warnings that will necessarily show up. If you can set the log level to critical, and none of the warning messages will show up. These are messages that you want to deliver either to a log file or to the user to the console. So these are just names. These methods that are dangling off the logging here, this is just a way of specifying what message you want to set for a given log level, okay? So here the debug isn't actually doing any debugging. This is a debugging message. And the warning isn't actually necessarily issuing a warning. It's a warning message, which will show up if the log level is set sufficiently low. But if it's higher than warning, then the warning won't show up. So you can think of it, this is a logging.error message, which will only show up if your log level is. Does that make sense?
Yeah, maybe I'll
Just to clarify,
yes.
None of the messages show up unless you put them in your code.
That's right. Yeah. So these are messages. So here, this little simple function is only testing the messages. But this is the sort of thing that you would write inside your own code, like logging, debug, adding A plus B here next, or about to access the database. Logging info. The username of this person is such and such, and the time is whatever, and there's this much amount of disk space left. Warning, the current, the disk space is low for the operation that you're about to do. We may run out of disk space if the user doesn't do anything. So but these are things that will be up to you, because you're the one that wrote the code, so it's up to you to instrument it however it is that it's going to be most informative to you. Yes?
Can you show a really simple example of how you might do that?
This is it?
I mean, like, in a program,
So this is a program. This is logging 1.py.
But the whole point of this program is just to generate those messages. But if you were actually writing some code and you got to a point where you had an error,
sure,
and you wanted that to show up, how would you implement that?
So you just take snippets. So you'd have with your imports that you already have, you just add the top three, okay? And then anywhere in your code, so you have some code right now that maybe it's a function that says, my integration, right? And my integration does something and returns some value. In the middle of my integration, you can now add a logging.warning, I'm trying to integrate over, like a point rather than an interval.
Maybe a source of confusion might be the difference between logging and exception. So if we have an error, we have a logging.error. That's just a word. That doesn't mean anything. That doesn't raise any exception. You could do logging.error, something really bad just happened, and then you could raise an exception if you really want to. But this is really just for you to mark up your code wherever you want to at different levels so that you can go back and inspect what happened in a long-running code by looking at the output file. So it's not actually sort of messing around with how the operations of your code work, or it's not actually changing your workflow. It's just giving you different levels of information. So the zeroth order part of this would be, a replacement for this would be every time I want to know something and save that information into a file, you just open up the file, write something into the file, close the file. That's effectively what logging is. But this just gives you conveniently different levels.
And I'm just going to restate that in yet another way, is that exceptions are sort of, unless you catch them, they're terminal events, right? It's sort of like your code is broken, like I can't do anything, right? When you catch them, you could report them, but then it sort of gets hairy. This allows you, so logging allows you to sort of, to sprinkle breadcrumbs through your code of what is it that actually happened for a given execution, right? It gives you a way of sort of, so there's, you may already do some sort of logging, you don't call it that, and it's not very convenient, but if you had print statements all over your code, think of these as print statements all over your code that you can conditionally put in and take out using this log level. That's really what it is. Maybe I should have started with that. Because everybody knows how to debug with print statements, right? I mean, that's sort of, it's pretty common tactic. Think of the logging module as just fancier print statements that you can sort of put in and take out with just a simple switch instead of having to go in and either leave them all in or keep taking them out. Is that better? Yes?
So one thing confuses me is if you don't define that make underscore logs, so you still get a lot of debugging information, right? If you set the logging level as debugging.
That's right, absolutely. So the question was that if you don't define make logs is a function we're making for our code. It doesn't need to exist at all, right? This happens to be, for this sort of toy example, make logs is the function that we want to sort of be writing. Make logs might as well have been, my integration function or whatever. It's not necessary. The only thing that's necessary in order for you to get started with logging are the first 3 lines of that program. And after that, how you use that logging is up to you. You can put it in anywhere and nowhere, right?
Just a more realistic example.
Well, sure. Thank you for the suggestion. Oops. All right, let me put up the next slide. So this is what I was talking about, is how there's a you can actually have these logger objects that that in the future, elsewhere in your code, if you were to import logging and get this logger, you will sort of be writing to the same file. You won't have to do the definition over again if it's already been instantiated. So this allows you to have sort of multiple loggers and disable them at will. Maybe you want more for your database access portion of your code. You want more verbosity, and for whatever else is going on in your code, you don't care about it at all. Okay, so this is a way of having sort of multiple logger objects.
So just to clarify, if I call hit logger twice in different parts of the code with the same identifier, I'll get the same logger back attached to the same file.
That's right. Yeah. Yeah. So that's what the logging module gives you is sort of a manager for these loggers. Okay, so you can use assertions in your code to make sure assertion is something that must be true, and if it isn't, it will raise an assert error. And the thing to know about assertions is that they may be taken out as written. So that's valid Python up there. So the type of value must be a type of the same as a string, right? So that's sort of what that's checking. And then it'll just try to print it, because otherwise the addition of this string with val may not be defined if val is not a string, right? So and so when val isn't in fact a string, it'll throw up that error. But if you something to note is that some Python interpreters and some people run Python in this optimized mode, which may speed up your code sometimes. These assertions get taken out. Okay. But there's a workaround for this, and that's inside of NumPy. There's a testing module. So NumPy is a heavily tested code base, and if you import numpy.testing, then you can use. Can you guys still see this? So import numpy.testing as npt. That's just sort of a convention, just so I have fewer things to write here. And if you do npt assert underscore and use it in the same way, sort of what the condition is. So this would be the condition, and then the descriptive message that you would want to send. If that when should that assertion raise? Should that become an error? This assert underscore method does not get taken out. So that's something useful. Yes.
So if an assertion fails, the code stops.
Yes, the code stops unless you catch an assertion. It's just another thing that you can catch, right? Yes.
The second question: what does underscore at the end tend to imply?
Underscore what? Sorry.
What does underscore at the end of a function name imply?
Oh, it doesn't necessarily imply anything. In here, the reason we use this is because assert is a reserved keyword in the Python language. And it happens to be also the case that NumPy testing has many other assert under something, like assert under almost under equal, or assert under array under equal, things like that. But this assert is sort of just like the... Does that answer your question? All right, so this is an overview of what sort of, in order to get to nose, it just talks talking a little bit about what it does for us, what a testing framework provides for us. So nose will go through your code and try to pick out particular files, particular directories, and functions within files and directories that look like their tests, usually by their name. So if you have test underscore something in a file name, and nose sees that, then it'll try to execute the things in that, the tests inside of that. And it will also, so it'll find all those tests, it'll run them, and then it'll report back to you a summary of which one of them passed and failed, and also allow you to go in, and depending on how you invoke nose, it'll allow you to go in and say, I want to invoke the debugger. As soon as there's one error, just put me in the debugger in that state, wherever it is that the thing failed. I want to know, I want to take a look around and see what's going on here. Okay, so like I said, there's several tools and frameworks, but we pretty much just use nose because that's sort of the community standard at this point. Is this the example that I wanted? Okay, yeah, so let me pull this up. Oops. So this is example 1. And so if I run nose tests, so here I'm running nose, and inside, let me show you what nose example 1 looks like. So nose example 1 has a class, transmogrifier. It has a method, test transmogrify, and it has a main function, which is what will get called when we just call Python transmogrify, or a Python file name of the file. And I just want to show you what So this is, I just added a doc string to this method, test transmogrify. So this is what I was talking about. The nose will discover this. It'll just know, based on the fact that I'm trying to nose test this file, it actually knows that the error occurred, and then it'll give me the doc string of the first line of the doc string of the actual method that it tried to run. So before I had this, it would actually tell me the method name. So here, I've gone back and I've removed that. And so if I do it again now, you see it tells me that it's inside nose example, and it's this thing that actually failed. Okay? And so here we had some tests, and we wanted Calvin and Hobbes to be zapped and transmogrified, but that didn't work. And can you see why that didn't work? So sorry, let me just step you through. So what nose is going to do is it's going to look at all the things in this file and look for things that look like they're tests. It'll find only this one, and then it'll go ahead and try to run it. So it'll instantiate the transmogrifier, and then for iterating over Calvin and Hobbes, it'll try to transmogrify them, and make sure that the thing it gets back is something other than just none or a new person. And it turns out that it'll actually just error out. And the way that is that okay? And this, you guys have this code, yes? Show of hands, have this code? You should probably get it, because we're just going to keep going. It's going to be hard for me to flip back and forth. I mean, I could keep this going, but it's just going to be easier. Whoops. All right. So this is I'm inside the example1 directory, and I'm just running nose test nose example.py. So it's telling me it ran one test, and what's the actual error that we get? We get the traceback back, and the error is key error Calvin. Okay, so it's capitalized, right? And how do we define in our code? The dictionary lookup is actually lowercase, right? So if we go in here, if we want to be sort of case insensitive when we use the transmogrifier, right? Person will be a string that gets passed to us. We can say lower, right? So that the new person will do a dictionary lookup into our dictionary with the lowercase version of whatever. So we can use mixed case, Calvin, Hobbes. You can do camel case, whatever. It'll just get converted up. When we do the lookup, it'll get converted to all lowercase, which are all valid keys in our dictionary. And so let's see if that works. So I'll save this file. And there you go. And all you see is this little dot, right? So in nose, the way that it reports something that worked is it'll put a dot there. If it failed, it'll put an F, and then there's ways of extending that NumPy and IPython use that will maybe put a K there where it's a known failure, maybe on your machine, or sort of the code base is such that there's two different ways of doing it, and it's known that one of these ways just doesn't work, and so it has a way of capturing that. And the other thing that you may see are S's, which are skips, which maybe you're on Windows, and this is a test just for Linux. And so just so you know sort of what the lay of the land is. But so this is the sort of the best thing that you can see in a test suite is that ran some tests and everything passed, and all dots are S's, and it'll tell you as it did for us earlier that here when it fails and with how many errors and things like that, right? And so you can actually pass this -v argument to see what the test names are that are running. So in this case, again, remember it's printed just the function name. If I were to have a doc string for that function, then it would, let me just show you. It'll just show up there. So you can have descriptive ways. So in IPython, or in all these modules, we try to, within the doc string, if it's a test for a known bug that was reported on GitHub, we'll try to put the GitHub sort of number of that bug within the doc string. So it's easier for people to report back saying like, bug number 1286 should have been fixed, but it came back again with with the latest version, and it's just an easier way of keeping track of what it is that works and what it is that doesn't work. Okay. So these are the gives you examples of the sort of things that it knows would have found, sort of how it finds the names of the things that it knows to try to test. And there's also ways of specifying, skip. I know this has the word test in it, but it's actually a statistical test that I'm calling test. So just don't try to run those. Okay, so this is just going over what we just did. Tells us the line number that the error was on, and sort of that we get free from the traceback, and then they made the same change of going to lower, and then all the tests pass. Okay, so doc tests are another way. If you look at the NumPy documentation, sort of if you do pretty much anything in NumPy, even just the array, you'll see it has different parameters, and then it has these examples, right? And those examples are, they live within the doc string, okay? But they actually get run, right? So the documentation is one of these funny things, right? It's not necessarily your actual software, right? It's the map, not the territory, right? Your documentation can say any number of things. That doesn't mean that the code actually does the thing that documentation promises. Okay, and so what doc strings allow, what doc tests allow you to do, which are, these essentially like a Python prompt input and output written inside of the docs. What those allow you to do is more tightly couple what the map is, how true of a representation the map is to the actual territory, right? So it will actually go through and verify that running np.array with that input will result in that output for us. So that's what doc tests are. And so there's an example of how to. I'm going to speed this up, but you can, since you have the slides, you'll be able to go through this with the actual examples of how it is that. So there's a simple file there, doc test example, where it's multiplication of A and B. The actual code only just does A times B, but within it, it has an example and the expected output. And if it doesn't work, then the doc test will fail. And if it does work, then it'll pass and sort of report to you. Okay. So if we add a 1 there, then the doc test will fail. This is just adding another example of that. Okay, this is just adding doc tests to the Calvin Hobbes example that we did. So you can mix these, and so long as you have the right invocation for nose. So this is at the command line, just so you're not confused. This isn't within Python. Nose is a Python program, but the way you invoke it is the same way that you invoke IPython. You just do it from your shell. Okay. So nose test, the thing that you want to nose test, and then you specify that you want it with doc tests, and you want to be very verbose about it and things like that. And so it'll report everything to you. It'll actually report to you the exact things that it ran, and if it's a doc test, it'll let you know that that was a doc test.
You want to show how to do doc tests with IPython, where you actually...
Yeah, so yeah, that's right. Thanks, Josh. So I showed you guys this, but you guys didn't know about docs yet and doc tests and why it might be useful. So there's a doc test mode within IPython where all it does is it switches the prompt to something like the traditional Python prompt so that you can go ahead and do things in here and then copy paste them into your doc script. Okay? And you can always, as I've said, so you can do np array ABC. Okay, and so that was a printout, and I don't really want to exit. I want to turn off doc test mode. You can always paste things from Python documentation into IPython. That will just work, right? So we remove these guys for you, but it's nice to not have to, by hand, remove these in and out prompts and just go back to the traditional Python shell, which is what we did here. So that's what doc test mode gets you. And if you want to know more, I don't know if there's more to know, but I guess there is. You can look up the doc test related documentation. Okay? I think these slides are really good, and the exercises that are in them, I think that you can pretty much, now you have sort of the high level overview of sort of lay of the land that you can figure a lot of this stuff out on your own, and I'll totally be around to help as well. So next thing is test-driven development. The easiest way to sort of code and to have peace of mind is, I mean, somebody might say, well, I have a really large code base. It's really going to be a pain in the butt for me to go back through and figure out what all the different code paths are that I need to change. Yeah, sure, that is really hard. But the thing that you should be doing, and the much easier thing to do, is upfront write the tests. And I really mean write tests of what it might mean for your module to work, right? Write out a set of tests of, without having any code written, so that it's just going to flat out fail on the first thing, right? It's just going to say, like, I can't even find this class. What are you talking about? But once you have that test written down, then you can start iterating, right? And it's this, so test-driven development is the idea is that you write your tests first, and you center everything around tests. You don't add a new feature before you added a test for it, because that's how you know when you're done. When your test passes, you're done. You've met the contract, the minimum contract that you established for yourself. If you want to extend that contract, you write out the contract first, and then you actually do the implementation. You don't try to make an implementation and then try to test what it is that if the implementation does the thing that you wanted it to do. Does that make sense? So in the directory called animals, sorry, you can step through each of these files. Let me just show you. Each of these files, so there's animals _ 0, 1, 2, and so on. So 0 is how you should have started, what it should have looked like when for an animal to speak. You can see there's no animal class anywhere in here, right? So it's just, if we just run nose, you're just going to say, what are you talking about? I don't even have an animal defined, right? But as you can see, as you work through it, then you can define an animal, right? And you can sort of give it some functionality. You already have the tests sort of fixed, what it would mean for an animal that is an owl to move. Like what that should look like, what that should return. And so you can sort of iterate through, and when you run the next test, then bam, everything sort of works. So now you can write the next set of tests and so on. Does that make sense? There you go, we did that. So then you add additional requirements, and you iterate. This allows you to sort of not feel like I have no idea what it is that I'm actually working on after you put down your code for a little bit, right? Is that either the thing that you've written tests for works or it doesn't. If it doesn't work, that's what you need to fix. And if it does work, then you can move on to something else, right? running a bit long here. And so here's more examples of sort of doc strings. Blah, blah, blah. All right, so PDB is, I think I'm just going to skip this because the slides describe it pretty well, but it's basically if you have an error, you know, like say, oops. Inside this animal thing, let's just put you know, divide by 0 error. And now, so there was an error. I can specify -- PDB flag. So now I'm in the Python debugger, right? And so it got me to the line of where the error occurred. And I can, using the list command, these commands are also all in the slides. Using the list command, I can get sort of a context of where it is that I am in the program. And I can go up and down the stack trace. So this move function was called from somewhere. So where was it called from? And we have this concept of a stack a call stack, basically, that, you know, the main program calls, you know, animal, and the animal class has a move function that may call something else, and so these things like a stack of plates just keep getting out of the top. As you return from functions, then you pop from the stack, from the top of the stack. So if we can go up the stack to see, well, yeah, don't worry about the up is just the convention for it, but this is where it actually got called from, and if we go up again. It was just, we're inside of nodes, right? It tells us which actually file we're in, so we're inside of nodes once we go up out of that. And then you can go, you know, you can go down, get the listing again, and so you can get what is self just by printing self, and what is self.name in this case, it's an owl, and so on. So you can sort of explore what it is, and there are some things that are reserved for PDB. So for example, what if I had a variable called up? How would I sort of, up will get me up the stack, PDB sort of overrides that. You can always do a $sign in front of some Python code and then execute that Python code. So if I do up here, it'll just say name error. I don't know what up is because I'm trying to access the variable up in the Python use case. Okay. Okay, so this tells you how to invoke PDB, how you can set traces. So you'll pop up in a given place. Like I only want the debugger to pop up and let me interact with the code base when I get to this point. So I did that sort of in a hacky way by putting an error there, by putting a 1/0, and that will stop my program from executing from there. From that point forward, it'll just. The program is dead. I can only explore the stack, the artifacts of my program. But you can actually set traces so that you get the debugger, look around, and then when you exit the debugger, the program will continue running. Okay. Here's how you can run it. In IPython, as I showed you before, when there's an error, so you can explore this on your own, you get that stack trace, and if you've enabled the PDB calling automatically, which in this case Dan did by invoking the PDB magic, and it told him that it's on. Like the doc test mode, it's something you can toggle on and off. So here he invoked it on, and so he went straight to IPDB on an error. If this was off, he would have gotten the error, and he would have gotten the out4 prompt back, and then in that prompt he could have typed in debug, and that will have gotten him back into IPDB. So here are the basic PDB commands that I showed you using help. Listing, how you can continue once you've, this is if you've set a trace. You can't continue if it was an error that was caught that brought back the debugger, and so on. Show you how to do this. Okay, so this is just a recap. I'm finishing up here of what it means to have a tested, well-written software project. Step 0 is you have to version control everything, right? Because how are you going to keep track of all these different permutations of things and what it is that you are working on? I think of a version control system as being like a flywheel that allows me to first of all, mentally turn off when I'm not coding, turn off my brain from all the different minutiae that are going on inside my code. But then when I am ready to code again, I just do, I do a git log -p to see what are the latest things that I checked in was. So -p will get me the patch, the diff patch that we were showing before. And then I'm like, okay, this is where I was, and now I can get started again and jump in and go forward. And so, and when tests that used to work for a while start breaking again, you can just see, oh crap, I didn't actually test this before checking it in, and now this thing is broken. What was the last set of things that I checked in that broke this thing? Instead of having to go back through, what does this test do, follow its code path, and so on. You can just go back, what was the last thing I did? Oh, okay, that was it, and flip something, and you're done. Okay? Okay, so this is some people are already chuckling that I have Russian in my console. So this is a Russian saying, the "доверяй, но проверяй," and you might know it by its sort of westernized version of "trust but verify." Sounds better in Russian, but and that's basically this is back to the thing that I started with: is how do you know that you're standing on firm ground? How do you know that all of these tools that we've told you about, yes, there's companies built around them, yes, there's all these packages, but how do you know that they actually work the way you want them to work? How do you know that they work for the thing that you care about? And the answer is you don't until you try to verify it, right? And so, and when it does work, on this machine today, how do you know that it's going to work on your next, fancy machine? How do you know it's going to work on the cluster that you're going to be running on, or on the, on Amazon's EC2? Okay, so let me just show you this really quickly. So we have, like I told you, all these packages that you're working with have tests, and many of them have extensive test suites that actually can be invoked. This turns out this also uses nose sort of in a more Pythonic way, but it's nice to have packages that have just a test method, because then within Python you don't need to know what the particular invocation is, whether or not the doc tests should be tested or not, things like that. So for NumPy, it just tests, and for many of them, it just tests. Just look at how many. So each one of those dots is a test. And some of them are actually testing more than one thing at a time. And we've just run 3,000 different tests. Turns out there's 0 errors and 0 failures. And these are the Ks that I told you about are the known fails. So these are things that are part of the contract, but where we're saying we're not going to do this. This is excluded from what we guarantee for you, right? And you can look at those and see what they are. And the S's. Oh no. The S's that you saw there are probably platform-dependent things. That's probably, I'm running this under Debian, this is probably a test for Mac OS or Windows or something like that. Or for IRIX or AIX or some Sun OS, something else. Yes?
What is this testing?
This is testing NumPy. So NumPy comes with 3,000 tests of different things. And you might say, what are those tests? Well, NumPy test has this verbose thing. So let's just set that to, I believe if we set it to 10, they'll actually print off all of the tests that are running. Like the names like we had before, right? Okay. One other thing that I want to mention is that once you have testing and version control, I don't think we talked about bus factor at all, right? Okay. So once you have testing and version control, you can have a pretty simple way of increasing your bus factor. So what's a bus factor? A bus factor is how many people need to be hit by a bus in order for your project to completely just disappear, right? So most projects have a bus factor of 1. That's you, right? And if you're a user of a project that has a bus factor of 1, think about how much sort of trust you're putting in that person and how sort of icky of a situation you could find yourself when your entire dissertation rests upon, some other code out there somewhere that only one person in the world, another graduate student maybe, is working on, right? It's much easier if you say, well, I'll help you just so long as we do it in a sensible manner. Let's have version control, let's have testing, so then at least I can know what it is that works and doesn't work currently, and so that we can develop together and start to build a community. All of this stuff started as one person or a small group of people, and it's when you decide to start sharing things and when you decide to leverage other people's code that you really need to worry about this stuff, right? So now you know what a bus factor is. Oops. Left. And so this is the thing that I was talking about. So this is a slide that Stefan made, where over time, the more and more time you invest in a code base, if the code quality is poor, if we call that spaghetti code, if you're just sort of hacking everything around, if my host name is this and I'm on this machine, I must be on the cluster, and then I need to do this fancy thing where I load a module, whatever, you're always going to become more and more afraid to experiment, to change things in your code. Because it worked yesterday, and I don't really want to change this thing because I didn't really test it, I just know that it worked, and you're just entering a world of pain, right? Whereas on the other hand, if you test everything, you have a little pep in your step, because everything works exactly as you specified, right? And the things that don't work exactly as you specified, maybe you haven't specified them yet. And if something is, ambiguous there, that's something that you can work on further. But at least everything that you wanted to test, you have verified will continue to work the way that it's supposed to. Okay, very scientific graph, by the way. This is very data-oriented. And so yeah, this is just the same thing. With gain confidence, leverage abstraction. You can spend more time exploring, your code for some application as opposed to working on the code, right? That's what you want to do. You want to be able to know that no matter what you throw at your code, it's robust enough that if the file system should fill up, you've taken care of that. Or at least you'll have a log error message and it'll sort of fail gracefully. If the database is inaccessible, it'll still continue working or whatever. It'll have some fallback mechanism, or at least it'll tell you in a sensible way that, hey, look, this run, just don't even look at it. Right? So the breakout that I have for you is to look at the code that we had there. You can start practicing test-driven development. So there's a few things. One is you can start practicing test-driven development by extending and adding another animal to that set of animal modules, right? Or extending the functionality of what those animals do. And you do that by first writing tests, right? And then writing the code that implements that test, right? Write the contract first, then you try to meet that contract. Once you've met the contract, you're done. And then you rinse, repeat. Till infinity. Okay. The other thing that I want you to do, and I did this sort of in a very friendly manner, welcome you to the community on the first day. I'm still really glad that you're here, but if you're going to stick around, I want to put you to work. This isn't yes, you didn't have to necessarily pay for these tools, but I want you to run the test suite for NumPy, SciPy, and IPython. And the way, I'll get to how to do it in IPython in just a second. But I want you to run those test suites, and if there are any failures, I want you to report them to the project upstream, right? This is the way it works. These projects will only be as good as the users let people know. We might not have the fancy Ivy Bridge processor that you have, and we haven't tested it on all the different permutations. If you want this thing to be sort of robust, and if you want to get back onto the green graph, if that's where you want to live, there's a little bit of a payment that you have to do, but it's pretty simple, right? I mean, all you have to do is run the test suite. When something fails, you now know exactly how to report what that failure is. You can just, copy paste the traceback that you get and just say a little bit something about what machine you're on. And if you don't, somebody will get back to you and tell you, this isn't specific enough. Can you tell us about what version you're running and things like that? But the point is that you get into the conversation. A lot of people say, like, I'm not ready to write code that some other people are going to use. I don't have anything useful to contribute, or I don't have very good expertise, or whatever, my code is spaghetti. You don't have to. This is a pretty damn good way to get involved. This is how I got involved, right? Is something just wasn't working on my machine and I reported it, right? And so you file a ticket on well, most of these projects are on GitHub now, so you'll just file a ticket on GitHub and then somebody will get back to you. Any questions on that? And so the last thing that I want to say is that, also, welcome to the community. Make yourself useful. And the last thing about this is that is back to a more philosophical point. I opened that slide of me at a march on the Oakland port back in December, and there's something that I learned from being involved with this isn't going to be political, but it's just something that I learned from being involved with the Occupy movement, and that is that it's very process-oriented. What I mean by that is it's the opposite of being outcome-oriented. If today you do things in a way that's consistent with the sort of feeling that you want to have about your work, that can never be taken away from you, right? If the only thing that you care about are the results, and you don't care which path you took to get there, not in a nefarious way, but just in a lazy way, or in a what seems like the most efficient path to the end zone, to mix metaphors, is that you will find yourself on the red graph, I guarantee you. Because for all the things that I've told you today, I am, on many of my projects, I am on the red graph. And this is why I care a lot about this, right? This is why it's just, trust me. Trust but verify. But I don't think I wouldn't want you to verify this for yourselves. I think, to put this another way, I can't really tell you something that you don't already know is true, right? You're not going to believe just anything that I say to you. But if any of this sort of rings true to you, I think we've outlined here what it is that you can do to get on a path back on that green path. So thanks. All right, so as you already saw some of my notes, I'm going to be talking about testing, and I'm mostly going to be using slides, excellent slides made by Dan Stahl. Is Dan in the audience? Not. Was he here first, Dan? He was here earlier. So these. Is it? Yeah. These things work better. Okay. Okay. Gonna do it live. Do it live. Okay. So these are slides that made by Dan Stahl. Oh yeah, so I'm Paul. Hey, how's it going? Welcome back. 3 days, you guys made it. This is like an awesome turnout. I'm pumped to be here. I don't know if you guys are. All right. I just wanted, Barry got a chance to do a stand-up. I kind of want to do the stand-up too. This whole academic thing, in case it doesn't work out. I would just enjoy it. Thank you. Any hecklers? No. As a contract, what it means for your software to work, or what it means for the software that you downloaded, what it means for that software to work, then you can have your users verify for themselves that your software works the way that you intended it to work. It's not just a trust me, or it's not just a it works on my machine. It's a here, I'm showing you everything I've got. These are the specifications. This is what it means for my code to work. And you can verify for yourself. So, sorry, I'm having trouble seeing here. Maybe I will have to paste you back. All right, so Nose is the sort of the standard tool that we have, that we use in our community in Python. There are many Python testing frameworks of varying popularity. Some used only in some communities, some specifically made for a particular project. Nose is the one that pretty much all of the scientific Python stack packages use. And then we'll also talk a little bit about PDB, and I already showed you, and I think others have as well, how to use PDB inside of IPython and sort of how to move around. So hopefully we'll get through some of that as well. And feel, as always, feel free to interrupt me and ask questions. And tell me, when do I need to be finished by?
Let's see, we had you until 11:40.
Okay, cool.
But
Okay. All right, but before we can get to testing and debugging, let's just recap some things that were covered yesterday in dealing with errors and exceptions. And then Dan had some nice notes in here about the traceback module and how to do logging as well, because these are all sort of aspects of good software development that are useful for, so testing is one way to proceed forward, right? When you write down your test, what it means for your package to work. But when it doesn't work as expected on a given machine, how are you going to go about tracking that down, right? When it doesn't work, does it just not pass the test? It doesn't sort of meet the requirements. Maybe it's some numerical accuracy that your algorithm has. Is it just that? Or is it that it actually throws an error because the way that you coded all of your paths to files are with the /, which is which works under Unix and under Linux, under Mac OS, but under Windows that's not going to work. And shame on you for not using OS path module and OS path join to join different slugs and different directories. Because that's the beautiful thing about Python. And forgive me if I'm rehashing some of these things, but this stuff was important because the beautiful thing about Python is it is a cross-platform language, right? I see a bunch of Mac symbols staring at me, but I also see a bunch of Lenovo and Dell machines staring at me as well, right? And those could be running Windows, and you could be running Windows on your Mac, and all of this stuff works. And it works because we're using Python, and you want to write your code in order to gain the most benefit out of Python, right? You don't want to write things that are specific to the operating system that you're on. You don't want to write things that are specific to your computer so that after you lose it, it doesn't work. All right. Okay, so we're going to talk about testing, and yes, and this and it works.
The tarball is up now.
Okay.
You rewrote the agenda.
Cool. So yeah, we will be looking at some code, and hopefully I'll be able to navigate there. And all right. So many of these slides are made by Dan Starr, and you can see the date on that. So this was the bootcamp 2 years ago, I believe. So this is like almost exactly 2 years ago. That's scary, and they're very good slides. So if something, with testing, if something's not broken, you don't need to fix it. So that's what I'm doing here. All right, so testing. How do you know that any of the packages that we told you are any good? I mean, you can use them, right? But how do you know that they're going to give you accurate results? Well, you can check some of them by hand, right? But the idea is that if you have an automated way of writing down tests of what sort of